Hello everyone, welcome to VMS class. In this video, I am going to explain about the decision tree regression, a simple mathematical problem we can take, as well as we can see how can we apply the decision tree regression on a small data set. So decision tree regression is a supervised machine learning algorithm that is used to predict the continuous numerical values. The regular decision tree algorithm is useful for classification problems, but this decision tree regression is going to helpful for continuous numerical values prediction. Unlike the decision tree classification, as we know that, which is going to predict the categories. This decision tree regression can be used in different kinds of applications, like we can predict the house prices, we can predict the salary values, we can predict the sales forecasting and temperature predictions. In all these kind of applications, we can use the decision trees. So what is the main idea of decision tree regression here? The decision tree regression works by splitting the data into smaller regions. The concept is basically here. It works like a tree structure. So where the data, we are going to split it into smaller regions. Then we are going to predict based on the average value inside each region. Okay. So try to understand the idea. I will explain with example also. Decision tree regression works by splitting the data into smaller regions, and it will predict by taking the average value inside each region. So if we take one simple example, suppose we want to predict the salary based on years of experience. Okay, I want to predict the salary based on the years of experience. Then this decision tree algorithm, it is going to create some rules like if the experience is less than 3 years, okay, if the experience is less than 3 years, then salary will be 25,000. If the experience between 3 and 5 years, then the salary will be 45,000. It is another kind of rule. If the experience is greater than 5 years, then salary will be 80,000. So the decision tree regression algorithm is going to create this kind of simple rules. Based on these rules, it is going to predict the numerical values. Okay. Then how this decision tree regression works? I have written this procedure in very simple steps. I have not written the complicated mathematical equations. To make it clarity, so I have written this algorithm in the very simple way. How this algorithm works? The algorithm first finds the best split point. Okay, we need to find the best split point first. Then divide the data into regions. I will explain with a detailed example. Okay, just understand the steps first. Find the best split point. Then divide the data into regions. Then calculate the average output in each region. We are going to calculate the average output in each region. Then we are going to repeat the splitting process recursively until we get the best split. Okay. So unlike this linear regression problems, decision tree regression does not create any straight line. Here we don't have any formula like y equal to mx plus b type of concept. Okay, decision tree regression, it's not working based on this concept, but instead it is going to create step like predictions. We are going to create some rules based upon the split. Then we are calculating the average. Then the predictions are going to be done. Okay. Let's take one simple data set here. Example data set. I have the experience and salary. Now I have given the experience 1, 2, 3, 4, 5, 6 and salary 15, 20, 28, 40, 60 and 80. Now this is my input data set. I want to learn from this using the decision tree regression and predict the new value. Okay, based on the experience given. The simple tree idea, for example, take the model may split like experience less than 3.5. So try to understand. For example, the tree is going to be split, okay, based on the split point experience less than 3.5. Okay, so what happens here? One tree will be created. Okay, one tree will be created. Now, if experience is less than, okay, if experience is less than 3.5, okay, it's one kind of a split. And if it is greater than, then one kind of split. Now, try to understand if experience is less than 3.5, so what are the values will comes under this region? Okay, if experience is less than 3.5, you can get, okay, 15, 20, 28, right? Then if experience greater than 3.5, you will get these 3 points, right? So those are 40, 40, 60, 80. Try to understand how I am taking this split point. I will tell you again. But if I take the split point, experience is less than 3.5, okay, all those points belongs to one region, left side I am taking. Then if the experience is greater than 3.5, all the points that are going to be on the right side. So now try to understand this region has 3 points, 50, 20, 28, then 40, 60, 80. Okay. So try to understand now how it works basically. Okay. So now I am taking here the simple tree idea is experience less than 3.5. So if you take this concept, you know that what is the average of this? 15 plus 20 plus 28 divided by, okay, 3. The average is 21. The right side point, okay, the right side points 40 plus 60 plus 80. Okay, you know that 180 divided by 3, that is 60, average salary. Okay, left side average, right side average. Okay, now a question may get, the goal is you need to reduce the prediction error. Okay, we need to reduce the prediction error. Now, some of the terminology in the tree regression is root node. Okay, root node. The first split is, we can consider that as a root node. So we have leaf node, that is a final prediction. Okay, and split is nothing but the decision condition. I have given that experience less than 3.5. That is nothing but a split. And the depth. So depth indicates how many levels in the tree. Okay, how many levels in the tree. Now, if you notice that I have taken the split point, experience less than 3.5. How you have selected that? The decision tree regression algorithms commonly uses the mean square error. Okay, mean square error to select the best split. The formula for this, MSE equal to mean of actual minus predicted whole square. If you have multiple samples, the summation will work out here. Summation of actual minus predicted whole square. So you find the MSE, and if the MSE value is less, then that can be the best split. Okay. So in this example, okay, here, suppose we have data experience is 20, 1 for 20, 2 for 25, 3 for 30, and 4 for 80. Suppose the three splits are, okay, like experience less than 3.5. It means, try to understand, less than 3.5 means, okay, the first 3 points will come 20, 25, 30, right? So here, if you see 20, 25, 30, the average 20 plus 25 plus 30 divided by 3, that is 75 by 3. So totally you will get average at 25. So now the prediction for the left region is 25. It means that if salary is less than 3.5, the prediction is okay, this value 25. The right region, we have only 1 point, right? So left region 3 points are there. Right region only 1 point is there, 80. So if the prediction, okay, here 80, what is the meaning of that? Okay, if experience equal to 2, in this case, it is less than 3.5, prediction will be 25. If experience will be 4 or greater than 8, then prediction will be 80. Simple. Only two rules will get. Okay. Now, let me take one simple example here. Okay, the detailed explanation I will give you. Okay, decision tree regression problem. So please take a pen and paper to solve this. Okay, even I have given a very simple steps only. Suppose we want the prediction for the salary based on the years of experience. This is my data. Okay, very simple data. I am taking 1, 20, 2, 25, 3, 30, and 4, 80. The main idea of decision tree regression is, as we know, it works by splitting the data set into smaller regions. Okay. The algorithm tries to find the best split by minimizing the prediction error. Okay. As we know that we are using the mean square error. Okay. Formula is mean square error. Now try to understand. In this case, let me take the experience. Okay. 1, 2, 3, 4. So first you have to make, okay, the values in the sorted order. If you take the values in the sorted order 1, 2, 3, 4. Okay. This is the experience. First, sort the points. Now then it calculates the midpoints between the consecutive values. It means that 1 comma 2, what is the average? Between 1 and 2, what is the average? So 1 plus 2 by 2, that is 3 by 2, that is 1.5. Okay. This is the first split point. Now between 2 and 3, we have 2 plus 3 by 2, that is 5 by 2. Okay. Value is 2.5. This is one split. Okay. Then between 3 and 4, we can find one split, that is 3 plus 4 by 2, that is 7 by 2, that is 3.5. So now we got three split points. Try to understand. From the data, after sorting the experience values, I got three split points. One is 1.5, another one is 2.5, another one is 3.5. In the previous example, I directly took 3.5. Now you may get a question, sir, why 3.5 there? Now you got some clarity here. Now we have three split points, that is 1.5, 2.5 and 3.5. In this I have selected 3.5. Why I have selected? Because this 3.5 may give the lower MSE. Error value will be 3.5 is very less. That's why I have selected 3.5. Now the immediate question, so how you are saying that 3.5 is the best? Okay, let's do the tracing of this algorithm. The algorithm will try every split. It means it is going to take first 1.5, then 2.5, then 3.5. It will try every split. Okay, and it is going to calculate the mean square error for each split. Okay, it is going to calculate the mean square error for each split. Then select the split with the minimum error. Okay, we are going to select the split which is having the minimum error. Now, let's take the initial mean. I don't have taken any split, directly the full data set. Okay, full data set I am taking before splitting. The formula is sum of salaries by number of samples. Now, what is the salary calculation here? Total salaries 20 plus 25 plus 30 plus 80 divided by 4. So that is 155 by 4. The prediction is, okay, the average basically 38.75. So initially every prediction is 38.75 only. Okay. Even I have not performed any splitting. So initially for entire data set, the prediction will be 38.75. So now calculate the initial MSE. The formula is MSE equal to mean of summation of actual minus predicted whole square basically. Now this is my salary, actual salary 20, 30, 25, 30, 80. Now you know that without splitting for each prediction, the average is what 38.75, right? So for every prediction, the average is okay, this one. So prediction is the same. Now error, how can you calculate the error? 20 minus 38.75, that is minus 18.75. You can calculate the square of it, that is 351.56. Similarly, you can calculate the error square for all the other samples. 25 minus 38.75 minus 13.75 and square of it 189.06. So like this, you can calculate for 30 minus 38.75, that is minus 8.75, square of it is, okay, 76.56. Okay. Now, similarly, you can take this also 80 minus 38.75, that is 41.25, square of it is 1701.56. Now, sum of squares, you can calculate all the sum of squares, the last column sum. Okay, 351.56 plus 189.06 plus 76.56 plus 1701.56. Now you can take the total, this is 231874 and divided by 4 samples. Okay, this is the error 579.68. So basically this error is very high. So the tree tries splitting. It go for splitting process. We have 3 splits, right? Now 1.5, 2.5 and 3.5. So we have to calculate the split for, okay, the initial experience values. That split points now we are going to take. Now take the next step. Try split 1.5 first. The split rule will be experience less than 1.5. This is the first split rule we are trying. Experience less than 1.5. So what happen if the experience is less than 1.5? The values which are less than 1.5 will comes under the left region. Okay. Now we have only 1 point. So that is 120. This is the left region. Now calculate the MSE for the left region and then calculate the MSE for the right region. Then total it. Okay. Now left region is okay. Prediction is 20 because only we have one value. So prediction is 20. The error is 20 minus 20. That is 0. Mean square error. Now right region. Okay. Right region means there are 3 points. So try to understand from the data set. I am going to take the first split, that is 1.5. Then you take the right region here. We have 3 points are there. Now calculate the average of this. Okay, 25 plus 30 plus 80 by 3, 135 by 3, that is 45 is the average. Now the right region error table I am doing. Right region experience value 25, 30, 80. The prediction will be 45 for all. 45, 45 and 45. Calculate the error square. 25 minus 45, that is 20, 20 square, error square. Like this, you calculate the error square. And what is the average error? Okay, 400 plus 225 plus 1225, that is 1850. The total MSE is 1850 divided by 4. So that is 462.5. So this is the error, okay, which we have calculated for the split 1.5. Okay, 1.5. And similarly, you have to try split at 2.5. Now the split rule will be something like this. If experience less than 2.5, then left region will come 2 points. Okay, right region will come 2 points. Now calculate the average for the left region. 20 plus 25 by 2, that is 45 by 2. 22.5. Now for the left region, calculate the error. This is the actual value 2025. Our predicted value will be 22.5 for both, right? Now subtract it and square the error. 6.25, 6.25. So total error is 12.5. This is for only left region, and similarly you have to calculate for right region. So right region we have two samples, 30 and 80. What is the average? 30 plus 80 by 2, that is 55. What is the right error? Okay, 30 minus 55 whole square, that is 625. 80 minus 55 whole square, that is 625, error square. Now what is the average error for the left region? 625 plus 625, 1250 divided by, okay, 2, right? So the total error, you can calculate the total error here, okay, 1250 by 2, right? Okay, you can calculate the total error. Then total error can be, okay, try to understand, 1250, right? This is the total error. Okay, now you can calculate the total error, that is 12, okay, the first case 12.5, okay, 12.5 plus 1250, the total samples are 5, right? So totally 1262.5 divided by 4. So this is the total error for split 2.5. Okay, I am just calculating the average, okay, of this 4 left region and right region. And similarly, try for 3.5. The split rule can be experience less than 3.5. All the samples will come under the left region. Okay, if the experience is less than 3.5, then for this calculate the, okay, mean. 20 plus 25 plus 30 by 3, that is 75 by 3. 25 is the average. That will be the prediction. So left error 20 minus 25, that is 5, and 5 square is 25. 20 minus 25 minus 25, that is 0. 0 square is 0. 30 minus 25 whole square, that is 5 square, 25. Now calculate the error. Okay, total error 50. And similarly, calculate for the right region, only one point will have 80. So prediction will be 80. So 80 minus 80, error will be 0 for that. Okay. So now what is the total error? So 50 for the left region plus 0 for the right region. So totally 50. How many samples are there? 4 samples are there. So that is a 12.5. Okay, so if you see this comparison of all splits, for split 1.5, the total MSE is 462.5. Split 2.5, this MSE is 315.63. For split 3.5, the error is 12.5. So you can take the minimum, the best split. The minimum MSE is 12.5, that is 12.5, which is for split 3.5. So we can say that the best split is 3.5. So now we can create a decision tree, something like this. If experience is less than 3.5, if it is S, then prediction is 25. If experience is greater than 3.5, then it is no. Basically, the prediction is 80. So like this, we are going to create the decision tree. Okay, it is a decision tree regression basically. Now try to understand, if the experience is 2, what will be the prediction? If it is less than 3.5, then prediction is 25. So if experience is 2, prediction is 25. If experience is 4, okay, which is going to right side, the prediction is 80. So like this, we can create a decision tree regression. So please take this problem. Even I will share this link in the description. So please try to practice it so that you will get better clarity. Okay. Now the same thing, I will show you the program. How can we implement this in Python? Okay. So with a simple, this data set only, I will take. Okay. Here I am going to take the very simple example. Go to Google Collaboratory. Here, first step is import the libraries. Okay. So here I am going to import the libraries pandas as PD. from sklearn.tree import decision tree regressor. Okay, so this is the algorithm which we are going to import for the decision tree regression problem. Okay, now create the data sets. Okay, I am going to take the data set, okay, which contains experience and salary. Okay, so from this I am creating a data frame and I am storing that in the df and print the df. Now the data is ready. Okay, you can take any large data set, no problem, the same concept. Okay, so here this is my data frame. Now you can divide that features. Okay, what is the input feature? Input feature is X. Okay, that is the experience. Then output feature salary, that is now Y. So I have splitted. Okay, not splitted, basically separated. Okay, X and Y. So input values and output. Now you need to split that. Okay, basically this is a small kind of okay, data set. No need to do the train underscore test underscore split. Directly, let us take the model and test on a new data. Model equal to decision tree regressor. Okay, I have created a model, then train the model using model.fit. Okay, I have to pass x and y for that. Now the model is okay trained. Okay, directly I will take one sample for prediction on the test data. So it is going to take model.predictor. So please predict for the salary 4.5. Then that will be stored in the prediction. So I am printing the prediction here. The salary will be 40. Okay, so you can see that for the experience. Okay, for example, if the experience is okay 4, you see that 4.5, the salary will be 40, it is going to predict. For example, say if I want to predict the salary for 7, okay, 7, okay, in this case, you see that the 7, the salary will be 80. So like this, the decision tree regression model is going to predict based on the split points. In the split point, we are going to separate based on the average of that particular regions. Okay, so try to understand this very okay simple and very important concept. The advantages of the decision tree regression, it can work for nonlinear data and it is easy to understand. No feature scaling is required. It captures complex patterns also. The limitations can be it can overfit easily if the decision tree size is big, it is going to big, then the overfitting may come. Sensitive to small data changes and predictions may become unstable few cases. Okay, so the real world applications you can use in the house price prediction, revenue prediction, medical forecasting, demand forecasting, etc. Okay, so coming to the okay important points here, decision tree regression predicts the continuous values. It uses the recursive splitting. MSE helps to find the best split. So the predictions are the region averages. Okay, so decision trees can overfit easily. Okay, so this is a very important concept. Try to practice this. If you like this video, please subscribe to our channel for getting more updates on computer education. Thank you. I will see you in the next video.